Look up at the sky, and you see the sun, an incredible, blazing sphere of light and heat that has existed for billions of years. It sustains life on Earth, providing the warmth and energy necessary for everything from the plants in the fields to the energy that powers our cities. But the sun is more than just a simple source of light. It's a volatile, unpredictable giant, a dynamic ball of gas that constantly churns and releases energy. Behind the scenes, it's constantly in motion, creating powerful and sometimes violent events that affect not just the solar system, but our daily lives here on Earth. One of the most powerful and awe-inspiring phenomena of our sun is the solar flare. A solar flare is an explosive release of energy from the sun's surface and outer atmosphere. These flares occur when the sun's magnetic fields, complex, twisting lines of force, snap and realign, unleashing enormous amounts of energy. A single solar flare can release more energy than humankind uses in an entire year, often in a matter of minutes. Imagine the force of billions of atomic bombs exploding in an instant, all directed outward into space. These explosive bursts of energy are accompanied by coronal mass ejections, or CMEs, which are massive waves of solar wind and magnetic fields rushing away from the sun. The sun is constantly sending out these energetic particles into space, but during times of solar maximum, when the sun is most active, the flares and CMEs become even more powerful and frequent. When these particles hit Earth, they don't just fly through empty space. They can collide with our atmosphere, with effects that ripple out across our technology, our infrastructure, and our daily lives. Fortunately, Earth's magnetic field acts as a protective shield, our very own cosmic force field. This magnetic shield, known as the magnetosphere, diverts most of the harmful radiation and particles away from the surface. It is this protective layer that makes life possible on Earth, blocking much of the solar energy from reaching us directly. However, when solar flares are particularly intense, they can overwhelm the Earth's magnetic field, and the particles are funneled down toward the poles, where they interact with our atmosphere. This can lead to geomagnetic storms, a disturbance in the Earth's magnetic environment caused by the influx of solar energy. While the atmospheric effects of a geomagnetic storm are often seen as beautiful, auroras dancing in the sky, these events are far from harmless. The charged particles in the solar wind can cause significant disruptions to technology, particularly satellite systems that orbit beyond the protective layers of our atmosphere. Satellites are extremely vulnerable to solar flares, as they can fry delicate electronic circuits or shorten their operational lifespans. These satellites, which provide us with essential services like weather forecasting, communications, and GPS navigation, are directly in the path of this radiation. When a solar flare erupts, the high-energy particles can damage these satellites in ways that are often invisible at first, but the consequences can be far-reaching. From malfunctioning weather satellites that provide critical data to misfiring GPS systems that guide planes, ships, and cars, the effects can be significant. A widespread solar storm could even affect global communication networks, leading to blackouts on radio frequencies and interruptions to internet signals. Imagine being in the middle of a flight without any reliable GPS. Unpredictable and dangerous, wouldn't you agree? And the risks don't stop there. On the ground, power grids are also vulnerable. Electricity transmission networks are intricately connected and highly sensitive to fluctuations in magnetic fields. During a geomagnetic storm, the solar particles can induce electric currents in power lines, causing transformers to overload or even fail. This can lead to widespread blackouts, as seen in 1989, when a major solar storm knocked out power to the entire province of Quebec in Canada, affecting millions of people for hours. These blackouts don't just affect lights, they disrupt daily life, from transportation to emergency services. And in today's world, where so much of our infrastructure is dependent on electricity, the consequences could be far more severe. A strong enough solar flare hitting Earth could cause long-term disruptions, potentially knocking out power to entire regions for days, weeks, or even longer. That means no electricity to power homes, no internet, no communication systems, and no way of getting vital information out to the public. It's a scenario that could cause chaos, especially in densely populated areas. While the direct impact on humans from a solar flare itself is minimal, thanks to Earth's protective atmosphere, the increasing reliance on technology means the effects of solar flares can be far-reaching. Power grids, communication satellites, GPS systems, all of these interconnected systems are vulnerable. And for astronauts in space, it's a different story entirely. Without the shielding effect of Earth's atmosphere, astronauts in space can face significant radiation exposure during solar events. Without our magnetic field to protect them, astronauts are at risk of dangerous radiation exposure. This radiation can cause long-term health effects, such as increased cancer risks and radiation sickness. Solar flares are one of the biggest threats to astronauts in deep space or even in low Earth orbit, which is why space agencies like NASA continuously monitor solar activity to ensure that crews can be protected. During intense solar storms, astronauts may be forced to take shelter inside specially designed radiation-shielded compartments to avoid exposure to harmful levels of radiation. Luckily, thanks to advancements in space weather forecasting, scientists are able to predict solar flare activity with greater accuracy. Using telescopes and satellites designed to observe the sun, they track solar activity in real time, allowing them to issue early warnings about potential solar storms. With this information, satellite operators can temporarily shut down sensitive equipment. Power grid operators can take steps to protect vital infrastructure, and flight paths can be adjusted to avoid affected areas. Still, as we continue to advance our technological capabilities, we face new challenges. Our growing dependence on satellite systems, GPS navigation, and satellite communications means that solar flare events have the potential to disrupt nearly every aspect of modern life. From communication blackouts to power outages, these solar phenomena could test our resilience in ways we haven't fully imagined. Though solar flares may not directly harm us here on Earth, the consequences of their effects on our technology are undeniable. The sun is a powerful, unpredictable force in our lives, and understanding it is crucial. As scientists continue to study and predict these solar storms, the more we learn about the sun's behavior, the better equipped we'll be to protect ourselves from its potential disruptions. So, the next time you look up at the sky and feel the warmth of the sun on your skin, remember that it's not just a glowing ball in the sky. It's a cosmic powerhouse, capable of both sustaining life and causing chaos. Solar flares remind us that the universe is not only vast and beautiful, but also full of unpredictable forces that can shape our lives in ways we're still discovering.